Okay, so now we're going to look at dimension reduction by reducing the number of categories in a nominal predictor. So the example that we're going to use is Boston Housing. Boston Housing right here, chapter 4 files. Go ahead and download that file. Okay. And this is a data set that we've already looked at. Okay. And here is a description of all the variables that are present in the data set. So now the example that we're going to look at is ZN, the proportion of residential land zoned for lots over 25,000 feet. Okay. Now that may seem like an interval variable, but we're going to treat that as a categorical variable. So let's look at how many distinct values are there. So if you go ahead and copy paste it in a separate column, and then under data, if you say remove duplicates, okay, so now we have 26 unique values. Okay. 26 unique values, okay, if you use this as a categorical variable, will result in 25 dummy variables. Okay? So how can we reduce the number of categories? So instead of 25 or 26 or whatever, we have less number of categories. So one way of doing that is to prepare a chart like the one that we just saw, like that chart. Okay. So how do we prepare that chart? We do this by using pivot table. Okay. So pivot table now has this data set as the data range. Okay. So now let's see that let's put this in a new worksheet. Okay. Click OK. Fine. So now you bring in ZN as rows. So now we have the distinct values of ZN listed as rows. Okay. And we want to look at this from the perspective of the target. The target is cat MEDV, so we have 0 or 1 for cat median value. Cat median value is whether median value is 30,000 or more, 1, and then less than 30,000 is the second value, 0 or 1. Okay. So now we want to see how many observations are there in each of these categories, in each row label and each column label. Okay. So for that we can bring in any variable. So let's say cat MEDV itself. Okay. Now instead of sum, what we want is count. Okay. So change the field setting to count. So now we have how many properties are in each combination of row label and column label. So 422 properties are less than 30,000, 84 or 30,000 or more, and of that 422, 339 are from 0 for ZN value. So this row label is ZN. Okay. And ZN of 12.5, ZN of 17.5. So what we want is we want to express this in percentages. So both for all the values that you have the same 0 to 100%. Okay. So we want cat MEDV equal to 0 and cat MEDV equal to 1. Alright. So now what we're going to do is to express each row, we convert the frequency into a percentage. So 339, so which is B5, so divide by D5. This one would be C5 divided by D5. Of course, when you sum the two, it will be equal to 1. So let's make it into a percentage. Alright, now copy that all the way. Now you plot that. Okay, so that would be, plot that as that one, stacked plot. Okay, so now we have the distribution of, okay, so in each, for each category of Zn, this is what? Distribution of cat median value by Zn. For each Zn, what proportion is cat med V0, what proportion is cat med V1. Here we have to add one more thing. You have to change the X range. Instead of 1 through 26, we want that to be the Zn values. Okay, so now we have the Zn values. So %, cat med V equal to 0. Okay, for what Zn values? So the first Zn is 12.5 and then 18, 21, 25, 28, 30, 70 and 85, right? So they all are 100%. Did I miss one? 52.5? Yeah, I missed that. Do I have that? Yeah, there I have it. Okay. So 52.5. So all of these different Zns can now be combined into one category. Now 100% MEDV equal to 1, they are 17.5, okay, 90, 95 and 100. Okay. So an analysis like this can be done. So remember again, Make sure you understand that. You take a categorical variable that has too many categories and you want to reduce that. Now you use that as your rows and you plot against the target. You look for the categorical target, and then now you see what categories in the categorical variable all that but the same. Don't make any difference in terms of their predictive ability. So combine them into the same category.